Hey everybody, welcome to this video on monitoring Kubernetes with vRealize operations. I'm going to show you what we can do for vSphere with Tanzu, as well as other Kubernetes flavors using the management pack for Kubernetes version 1.5.1. And I've got some really cool things that I want to show you with that. So you're here, I'm here, let's just get right into it. With so many options for running Kubernetes, obviously there's going to be a lot of different options of how we can monitor these too. And so with this slide, really trying to highlight the differences when you would use one versus the other. So for example, if you're running vSphere with Tanzu, so this is formerly Project Pacific, right? This is running pods and namespaces and everything on top of vSphere. Well, these can be monitored through the native vCenter adapter in vRealize operations. So this works out of the box. There's no management packs to install. So you can hit the ground running with managing your vSphere with Tanzu. So for those of us that are traditionally, vSphere administrators, vSphere Tanzu is actually the lowest friction way to start getting into Kubernetes and to start providing these services to our organizations. And so with vRealize operations, we make that just as easy as well by being native through the vCenter adapter. Now, let's say you're running upstream Kubernetes, which is just kind of a fancy way of saying sort of, the general open source Kubernetes flavors that are out there. Maybe you have a Tanzu Kubernetes cluster deployed on VMware Cloud on AWS, or maybe even EC2, OpenShift, right? And if you're running any of these on a virtualized platform or bare metal, doesn't really matter as long as we can connect to it. We can leverage the management pack for Kubernetes to get insights into this. And then also want to point out that if you're running Tanzu Mission Control, the management pack for Kubernetes will work with that as well. So if you deploy a Tanzu cluster in AWS running on top of an EC2 instance, we can automatically pull that into vRealize operations. It's really cool. And so that's really the big difference between the native vCenter adapter and the management pack for Kubernetes, just at the very highest level here. Now, if you are running managed Kubernetes services like Amazon's EKS, GKE, or AKS in Azure, you can monitor those through their respective management packs. So that's kind of outside of the scope of what we're talking about today, because we are focused on the native vCenter adapter and the management pack for Kubernetes. Now, in the Venn diagram here, you do see a little bit of overlap, and I'm going to try to explain this as best I can. vSphere with Tanzu allows you to deploy Tanzu Kubernetes clusters. Okay, so you can deploy these right alongside your pods. They could be in the same namespace, they could be in different namespaces. And why you would want to deploy a Tanzu cluster on top of vSphere with Tanzu is, say you have dependencies on a specific version of Kubernetes, right? Every version, 1.18, 1.19, they make changes to their APIs. And so your software may have some dependencies on that. Or, maybe you have another reason for running an older version of Tanzu, or maybe your application or development teams need full access to a cluster and you don't quite want to give them the vCenter level of access, right? You can give them their own Tanzu Kubernetes cluster that they can then play around with and still be contained within just that cluster that they then own and get pet and love and all of that stuff, while you can still manage things at the vCenter level. So when you deploy a Tanzu Kubernetes cluster on top of vSphere or Tanzu, the native vCenter adapter within vRealize operations will allow you to see those nodes. Okay, so basically the virtual machines that you deploy for the control plane and for the worker nodes, okay, for that cluster. So you can see those all within vRealize operations. But if you want to dive deeper into that and be able to see the namespaces, the replica sets, the services, the pods, the containers that are deployed within that cluster, then that's where sort of a hybrid approach can work. Okay, so the native vCenter adapter will allow you to see, again, those nodes, but then the management pack for Kubernetes will let you dive a lot deeper and actually see what is running within those clusters. Okay, so that's why we have the overlap here in the Venn diagram. And I will show you this in a demo, so if it doesn't make 100% sense just yet, it will by the end of this session. And then just to take things a step further, the management pack for Kubernetes supports the following Kubernetes versions. So upstream Kubernetes 1.16 through 1.19. TKG and TKGI, same, 1.16 and 1.19. We support OpenShift 4.3 to 4.5. We also support Tanzu Mission Control. So again, being able to automatically discover and pull in those Tanzu clusters that were deployed with Tanzu Mission Control on EC2 instances. We can pull those into vRealize operations. And one thing that I should call out is that there were some API changes to Tanzu Mission Control. So if you are running an older version of the management pack for Kubernetes, like 1.5.0, you may not be able to connect to Tanzu Mission Control. And so that was repaired with version 1.5.1. And we've already talked about the managed Kubernetes services. So Amazon EKS, Azure AKS, and Google's Container Engine. Right, these are all managed services. These are services that you request from that provider, and they will stand up a Kubernetes cluster pre-configured, pre-built for you. So again, those can be monitored through their respective, Amazon or Azure or Google management packs. And then finally, the management pack for Kubernetes has support for Prometheus. So version 1.5.0 introduced Prometheus support, and we've built upon that in version 1.5.1. So this is actually more than just a dot release in 1.5.1. As you'll see here, it's actually, there's a lot packed into this one release, which you're going to see. And down here at the bottom, you'll see all the different objects that you'll get visibility into from vRealize operations. We can actually go pretty deep all the way down to the specific container level. And with Prometheus, we can actually go a little bit further. And I'm going to show you that here in just a bit. And just like our Venn diagram, we're going to split this presentation up into two different sections. So we're going to start off by talking about vSphere 7 with Tanzu, and then we're going to dive deeper into the management pack for Kubernetes and really highlight some of those integrations specifically with Prometheus. And so we're starting with vSphere 7 with Tanzu because, again, as virtualization administrators, this is the easiest, lowest friction way to get started with Kubernetes. We can leverage our vCenter and be able to deploy pods on top of our ESXi hosts and create namespaces. And as we start to get more and more comfortable with Kubernetes, maybe we want to get a little more advanced and start deploying Tanzu Kubernetes clusters easily. vSphere 7 with Tanzu can really grow with you as you get more and more comfortable and a lot more familiar with the various concepts of pods and containers and namespaces and all these new concepts, and really figure out how we can string them together to make it work for our organizations. And just like vRealize operations can help with your traditional vSphere environments, be able to manage capacity or do some troubleshooting with virtual machines and ESXi hosts, it can do the same for vSphere with Tanzu constructs as well. So again, those namespaces, the vSphere pods, your Tanzu Kubernetes clusters, we can use all of these objects and be able to tell that story of how much capacity am I going to have? When do I need to purchase more hardware? Can I deploy more Tanzu clusters on my existing hardware? We can create reports to show us areas that we may need to focus on. Do we have all of our resources configured correctly? Or, are we at risk for noisy neighbors consuming resources and taking them away from other applications? And we can use the out-of-the-box dashboards or create our own for our own specific needs. And we can also get complete end-to-end visibility. So we can go from that vCenter server all the way down to the pods that are running on it. And that's important not only to be able to understand kind of the lay of the land for our vSphere 7 with Tanzu environments, but also for things like the troubleshooting workbench or even metric correlation, right? These things can all play into these relationships that are native within vRealize operations. And this is an example of taking a traditional vSphere management concept like capacity and being able to take it a little bit further and apply it to Tanzu. So for example, we have a vSphere cluster selected that has 60 days remaining due to disk space constraints, okay? If we take a look at it from the VM perspective, how many more VMs can we deploy within this cluster? Well, we can build a profile based on our Tanzu nodes, right? Our various worker nodes, so we can see how many more of those we can deploy within a cluster, right? So that can be very useful, especially as development teams may need multiple clusters for a single project, and you may have hundreds or thousands of projects going on at any given time, it's nice to be able to know that you're going to have enough capacity to deploy those workloads, right? You can see it all through the capacity tab right here, but we could also model it with the what if scenarios, right? We could actually model the Tanzu clusters that we need to deploy and see what sort of impact that's going to have on our capacity over time. And you'll get the complete end-to-end visibility that you expect from vRealize operations, from your vCenters to the individual pods and the virtual machines. Not to mention, if you have multiple vCenters, right, you can bring all of those into vRealize operations and get an overview across your entire environment. So you'll know how many supervisor clusters, how many namespaces are out there, how many pods are deployed across your whole infrastructure. And all of this information is readily available. For example, the Workload Management Inventory dashboard provides us an overall view across the environment, so we can easily identify if there's an uptick in the number of pods that are deployed. We can get key performance indexes for selected objects across our entire inventory tree, and we can also dive a little bit deeper into the individual objects like our namespaces and see how they're configured. Do we have any limits configured? And if we don't, we can identify what limits should be imposed on these. We can also identify variations in our configurations across the environment. So using the Workload Management Configuration dashboard, we can ensure that all of our clusters have the same version of Kubernetes, for example. Because as many of us know, maintaining consistent environments can be very critical, especially when it comes time for upgrades, right? We don't want to be missing out on those major upgrades because we didn't deal with the day-to-day and making sure that everything's consistent. There's also a number of reports that are available out of the box for things like your pods, your Tanzu Kubernetes clusters, namespaces, and supervisor clusters. And these could all be automatically generated and sent to your email on a regular basis. And of course, vRealize operations can alert you when there are issues in your vSphere with Tanzu environments. So for example, if there's a pod that is unable to start up due to a lack of resources, or maybe a pod that's not in a running state, you need to know about these things as soon as possible. And vRealize operations can do that by delivering alerts to your email, or sending Slack notifications, or even opening up incidents in ServiceNow. These are all available out of the box with vRealize operations. So now that we've covered the capabilities for vSphere with Tanzu, let's take a look at the management pack for Kubernetes. And as of version 1.5.1, customers running vRealize Operations Advanced or Enterprise can take full advantage of this. And like I said in the beginning, the management pack for Kubernetes is great for managing your upstream Kubernetes, your Tanzu Kubernetes Grid and Tanzu Kubernetes Grid Integrated, OpenShift, and integration with Tanzu Mission Control. And as long as vRealize Operations is able to connect to these environments, it doesn't matter where they're deployed, whether it's on vSphere, physical, could be an Amazon EC2, or Google virtual machines. Now, of course, there is some benefit to running these on vSphere. For example, vRealize Operations can draw the relationships from that vCenter all the way down to the individual pods, because we understand that those Kubernetes nodes are virtual machines running on top of vSphere. So we can take our knowledge of the vSphere world and the Kubernetes world and map the two together for one complete view. And so for a closer look on the object relationships, here we can see how everything is mapped out. So for example, at the far left, we have our vCenter, and we can traverse through to the vSphere cluster, the resource pool that our Tanzu cluster is running in. We can see all of the different cluster nodes as virtual machines, and then through our understanding of the Kubernetes side of things, we can map that virtual machine to a node in our Tanzu cluster, and on that node run a bunch of pods and containers. And these relationships, again, are really great for things like troubleshooting, for example. We can leverage the troubleshooting workbench or even metric correlation to be able to determine if something happening in our infrastructure is impacting our pods, or maybe even vice versa. There's really a lot of power by having this complete end-to-end understanding of the environment. And with the management pack for Kubernetes comes a number of dashboards. For example, there's a great availability dashboard so you can determine whether your pods and your containers are running, or if there are issues that need to be addressed. For example, on the lower right side of this dashboard, we can see that there are a number of containers that are not available, meaning they're not in the running state. So we can very quickly identify that there's an issue in our environment that we need to go and dive a little bit deeper into to understand what is actually happening. And then if you're looking for a quick view across your entire Kubernetes environment, there's the Kubernetes Overview dashboard. So this will show you the total number of nodes and containers and pods deployed within all of your clusters that are being monitored by vRealize operations. And we can drill down and look at the overall health and identify our least healthy nodes. And by selecting the node, we can see things like the version of Kubernetes that it's running, key performance metrics like how much memory and CPU is being utilized by the node, and be able to view the object relationship, so what pods are running on this node and what's the health of those. And going even further into this dashboard, we can see the same for all of our pods. So again, all of this information is all within a single dashboard, so it makes it nice and easy to get all of this information in one place. And of course, there are alerts as well. So for example, for containers that aren't running, well, we want to know about that because that's going to impact the applications that we're expected to deliver. And these alerts are available for services, replica sets, and nodes as well. And the reports that are available in the management pack for Kubernetes will allow you to identify any sort of configuration issues or things that could be potential problems in the future. Now, one of the biggest things that we've introduced in the management pack for Kubernetes, starting with version 1.5, is integration with Prometheus. And if you're not familiar with Prometheus, it's one of the most popular metric collection utilities for Kubernetes. And so the cool thing here is that we can leverage those metrics that your developers and your application teams are already collecting. So we don't need to install new collectors or tools or things like that, right? We can just pull all this information directly into vRealize operations. So this can provide for a lot of flexibility, whether you're running physical Linux or even Windows-based nodes, we can get those metrics into vRealize operations. And regardless of whether or not you're running Prometheus, you'll still get that end-to-end view. We'll be able to see our Kubernetes clusters and also look at all of the namespaces and pods and services and replica sets and containers that are available within there. And plus, like I said, if you're running on top of vSphere, we can map those two worlds together so we understand where these clusters are running in your vSphere environment. So this sounds great, but how does it all work? Well, the management pack for Kubernetes has a Kubernetes adapter, and that adapter is responsible for collecting the inventory for your Kubernetes clusters as well as the metrics that are associated with them. So in cases where Prometheus is used as the means of collecting metrics, the Kubernetes adapter needs to make two connections. The first is to the Kube API, and this is what allows us to collect that inventory view of our Kubernetes clusters. So for example, what pods are running in what namespaces? They run on what nodes? What are the configurations of these? And once we know what's running in that cluster, then we can start to pull information from Prometheus. We can make that connection to pull in those metrics and apply it to those objects. So if we're looking at a Kubernetes node, we can see the metrics associated with that node. So this is just a quick view of how the Kubernetes cluster gets configured within vRealize operations. So you can see we have the URL for the control plane where we can query the Kube API to get that inventory. And then for the collector service, this is how we get the metrics. We can select either cAdvisor running as a kubelet or a daemon set, or we can use Prometheus, in which case we just provide a connection to the Prometheus server, and we can provide credentials too if we're using those. And before we jump into the metrics within vRealize operations, let's take a few minutes to understand how Prometheus works. Unlike vRealize operations, which has its own collectors, which know how to speak to whatever it is we're trying to collect metrics from, be it vSphere or NSX or a storage array, Prometheus gets its metrics through exporters. Now, an exporter is something that can actually connect to whatever it is that we're trying to monitor. So it could be a Kubernetes node, it could be a container, or it could even be the application that's running on that container. And once the exporter collects the metrics from whatever it is, it then exposes them, typically via HTTP. So those metrics are basically just sitting out there ripe for harvesting. However, Prometheus isn't quite ready to pull those metrics in just yet. What we need to do is configure jobs. And so jobs are really a grouping of metric collections. So for example, I have a Prometheus configuration here on the screen, and there's a job called Node Exporter. And within that job, we have the various targets. So these are the actual connections to the exporters to be able to scrape those metrics and bring them into Prometheus. And so you would typically have a job for each type of exporter. So in this case, the Node Exporters have their own job, and then the Redis Exporter is a separate job. And within these jobs, we can configure additional metadata, such as labels. So if you take a look at the Node Exporter job within our configuration, you can see each of the targets, which are the exporters, and then there's an additional label for each of them, which contains the name of the node. And once all the exporters have been deployed and the jobs have been configured within our Prometheus configuration file, we can then see the various targets that we're collecting data from. And so you can see very clearly here the two jobs that we have set up, the Node Exporter job and the Redis job. So in the Node Exporter job, we now have 4 endpoints that we're connecting to and scraping metrics from. And for each of those, we can see the various labels. So for example, that node name that we have configured for the job. And if we take a step further into the world of Prometheus, this is what the metrics look like once they've been scraped. So I have a query here to show us one metric, which is node CPU seconds total, for one of our nodes, which is one of our TKG worker nodes. And even though the query is just for a single metric, you can see that there are quite a few metrics that get returned. So even though the metrics all have the same name of node CPU seconds total, the labels are different. So for example, if you look at 2 of the labels here, there's a CPU label. We can see that there are half the metrics that are for CPU 0 and the other half are for CPU 1. And then if we look at the mode label, we can see that some of these are measurements for CPU idle. How much time is waiting for I/O? How much CPU is the system using? So you can see how labels are used to differentiate all the various metrics. Even though the metric name is the same, the labels are all very different. But wait, isn't this a session on vRealize operations? Why are we spending all this time talking about Prometheus jobs and labels and yada yada? Well, that's because they play a very important part in how this data is displayed in vRealize operations. So here I have a screenshot from VROps that shows us the Prometheus metrics. So I have selected an object. In this case, it is a Kubernetes node. And within the metrics of that object, I have a Prometheus option. Underneath Prometheus is Node Exporter. So that's the name of the job that we configured. And then the key values for our labels. So in this case, it's CPU and mode. And then finally, the label values themselves. And so this is how jobs and labels are used within vRealize operations to structure this data. And so if we were to ignore these labels, you can imagine what kind of a mess this would be, right? We'd have a dozen or so metrics all named node CPU seconds total, and we wouldn't have an idea of what CPU it is or even what measurement that metric represents. In some cases, you may have too many labels or labels that are irrelevant to you as an IT services provider. And so through the management pack for Kubernetes, you can selectively ignore certain labels, or you can also turn off labels altogether if that's your thing. When it comes to picking exporters, there are certainly a lot of different options, and it's going to come down to what your requirements are and what your environment is. And so the table here shows the exporters which are supported with the management pack for Kubernetes, and you can see that each one provides a different set of metrics and also support for different flavors of Kubernetes, whether it's Linux or Windows. Of course, there are quite a few options here, and if you're looking for a good starting point, whether you're running Windows or if you're running Linux-based Kubernetes nodes, the Node Exporter is a good option. Now, another really cool thing we can do with the management pack for Kubernetes is integrate with Tanzu Mission Control. So if you're not familiar with Tanzu Mission Control, this is basically lifecycle management for Tanzu clusters. It can do a bunch of other things as well, but in terms of the integration, any cluster that is deployed in AWS through Tanzu Mission Control can automatically be discovered and configured within vRealize operations. So we don't need to manually configure those adapters to see the inventory, for example, of our Kubernetes clusters. And the same is true for when clusters get deleted. They can be automatically removed from vRealize operations as well. Now, one thing that I should call out is that Tanzu Mission Control recently added the ability to deploy Tanzu clusters on top of vSphere, and that's not supported with the management pack for Kubernetes version 1.5.1, but I would expect to see that in the very near future. And with that, let's log into vRealize operations for a quick demonstration. We're going to start off by taking a look at vSphere with Tanzu through vRealize operations. Now, configuring this is just a matter of simply pointing vRealize operations at our vCenter, and that's it. We'll get insights into our vSphere pods, our namespaces, Tanzu Kubernetes clusters, all within vRealize operations. So nothing additional to configure here. So let's jump in and take a look at this through vRealize operations. So if I go into one of my vSphere clusters that has vSphere Tanzu enabled, go to my vCenter adapter, cluster compute resource, and then find my cluster right down here. Now on the summary page, we will get some important information. So for example, we can see that workload management is enabled on this cluster, meaning we have vSphere with Tanzu. And then there's other information such as your time remaining, capacity remaining, etc. And we'll get into that in just a little bit here. So let's jump into the metrics and look at the relationship view here. So we have our vSphere cluster, and there's a namespaces resource pool, which is where all of our Tanzu Kubernetes constructs live. Under the resource pool, we have all of our different namespaces in here. So for example, NetShoot. This one has 99 plus pods running in it. So I can take a look at this and grab some metrics for this namespace. So for example, hey, how much does this cost me? What is my month-to-date cost for running this namespace? And in this case, this namespace is already costing me close to $2,000. I can also see other information such as what is the CPU demand. So for all the pods that are running in this namespace, how much CPU are they asking for? And in this case, we're just looking at about 23 megahertz. So not a whole lot of demand going on here. However, with 99 plus pods running in this namespace, we want to make sure that we're kind of containing things a little bit, right? What if all 99 plus pods start going wild and asking for all sorts of CPU? Well, that could potentially impact other applications running in this vSphere cluster because we're now consuming so many more resources to feed this one namespace. And so with Kubernetes, there is this idea of being able to impose limits, right? Just like resource pools for vSphere, we can impose limits on various namespaces as well. So I can actually see what that is if I go into the properties of this namespace and configuration resource limits for the namespace. And we have limits for CPU, disk space, and memory. So in this case, let's take a look at CPU. And the value is -1, which means there's no limits imposed on this namespace, which is something I'm going to want to set up. Now let's take a look at pods. I'm going to go ahead and expand the Nginx namespace here. And within this namespace, we have 3 pods running. And by selecting this pod, we can get various metrics just like CPU, memory, how much does this cost? So what is the effective daily cost of running this pod? Well, it's about 14 cents a day, 14 cents per day. So this one's actually relatively cheap to run. But I can also get information like the guest file system. Well, how much is being utilized in my guest file system? Well, I'm only using about 33%. And of course, with all metrics within vRealize operations, I can configure alerts to send me emails, Slack notifications, or open up a ServiceNow incident if we start to see this utilization get too high, say 90 or 95%, right? We want to know that this pod is potentially going to run out of space and then be able to deal with that. And so along the lines of capacity, we can take a look at the capacity of our vSphere cluster. So if I go here into the capacity tab, we can see how much remaining capacity we have in this cluster based on our previous deployments. And we have more than a year's remaining worth of capacity, right? We haven't really deployed all that much into this cluster, so it's remaining relatively flat. So that's from a time-based perspective, which is nice because then I can plan out for future hardware purchases. However, if I want to look at it from a virtual machine standpoint, right, we can see an average virtual machine. So this is looking at the average size across all VMs that are deployed in this cluster. And I also have a profile for Tanzu Kubernetes small nodes. And so with this, I get a good idea of how many more nodes I can deploy in the cluster before I run out of capacity, which is close to 400. Now this gives me a good point in time for my current capacity, but what if I want to plan for a future project? Well, I can go into the what if scenarios. So if I go into the capacity pillar here and go under plan, I can create a new project to add virtual machines to my existing cluster. So in this case, I'm going to give this scenario a name and select my data center. So in this case, I want to go to my VCF workload data center and select my cluster. Now I can create virtual machines based on specs that I get from the application team or whoever's requesting these virtual machines, or in this case, I can actually basically take a clone of an existing virtual machine. So I can say for my existing VMs, look at TKG, and I've got my TKG cluster 01 right here. So if I select these two virtual machines, I can create a plan based on these. So I've got these in here, and then I'll just click OK. So I can also change things a little bit too. So let's say I want to deploy 20 clusters with one control plane and 3 worker nodes. So I can go in and I can adjust the quantity here. So I can say I want 20 control plane nodes, but then I want 60 worker nodes. I also have the ability to change my vSAN configuration, such as RAID levels and failures to tolerate. In this case, I'm going to leave everything as it is. And because this is just a short-term project, I'm going to do a start date of today, and the end date of May 3rd is more than fine for this project. So I'm going to go ahead and run this scenario. And so vRealize Operations has calculated whether or not there's enough capacity for this project. And in this case, there is within this cluster. And I can see how much it's going to cost me per month to run this, and that it really hasn't made any change to my capacity. There's still a year remaining. Now I can go in and view the details of this project and see how much CPU, memory, and disk space it's going to take. And I can also compare that to my existing utilization. So here's what I'm using for CPU today, and here's what we're adding for this project. And then if we look at memory, this is what we're adding for workload, and this is what we're left with. And of course, we can do the same for disk space. Now, if I scroll down, I can take a look at this plotted over time. So taking a look at CPU, we can see our existing utilization plus what the expected utilization is once we add these VMs. And of course, we can do the same for memory and disk space. So for example, here looking at the memory, I can see how much we'll have left over after we deploy these. Okay, so that's things from a capacity standpoint. Let's take a closer look at the Tanzu Kubernetes clusters themselves. So we're going to head back to our vSphere cluster, and I'll expand out the namespaces resource pool. And in the TKG namespace, I have 2 Tanzu Kubernetes clusters deployed. So from a vSphere with Tanzu perspective, I can see the 2 nodes inside this cluster, in this case these 2 virtual machines. I have the control plane node, and then I have the worker node. And if I expand these out, I can see the data store that these live on, just like any other virtual machine. So for many IT organizations, this level of detail is plenty because all we're doing is providing the cluster to our application and development teams, and we're only concerned with the performance of the virtual machines all the way through to the physical infrastructure. Now, there may be times when we need to dive deeper into our Tanzu Kubernetes clusters, and in this case, TKG Cluster 03 is also attached to vRealize Operations through the management pack for Kubernetes. And so what this allows me to do is dive even deeper. So if I take a look at this node here, I can expand it out, and I can see the data store that that virtual machine is running on, but I can also see the Kubernetes node. So now we're looking at it from the Kubernetes perspective. If I expand this out, I can then see all the pods that are running on this node. And so here we see our Prometheus pod, and if I expand this out, I can then see the container that is running inside of it. So now we've gone from the vSphere cluster through the resource pool into our namespaces, so in this case TKG, and we can see our 2 Tanzu Kubernetes clusters deployed on vSphere with Tanzu into all of our nodes. So what we're looking at here, everything on the left side of this line is from the vSphere perspective. And everything here on the right, from our Kubernetes node to the pod to the container, is coming from the management pack for Kubernetes. Now, in this particular cluster, I have Prometheus deployed. And so Prometheus is collecting metrics from all of the different exporters that I have deployed throughout this cluster. So I've got Telegraph, I've got Node Exporter, as well as an application exporter. And then vRealize Operations is collecting all those metrics through Prometheus. So for example, with this node, I can go into the metrics and see under Prometheus, I have Node Exporter and the Telegraph Exporter. So if I go into Node Exporter, I can take a look at some of the metrics for this particular node. So for example, how much memory is available. And in this case, I've got just under 8 gigabytes worth of free memory. So not a big deal here. But again, just like any other metric in vRealize Operations, I can configure alarms so that I know when it's going to run out of memory. Now, if I take a look at the Prometheus container here, I can go into my Prometheus metrics, and I can actually see how much CPU this container is using. So the cool thing here is that I can monitor Prometheus with vRealize Operations. And you'll notice that this metric is measured in nanocores. That metric is coming directly from the Telegraph exporter. Nanocores is one of the measurements used within Kubernetes, and it means 1/1000th of a CPU. So you can really tell how small of a workload we're trying to measure here. So this is one way to look at our Tanzu clusters, but let's take a look at it from the Kubernetes standpoint. So I'm going to go into this node here and then expand out the cluster. And then I want to go to the adapter instance that's connected to this Kubernetes cluster. So within here, now we can see our cluster. I can see all of the namespaces plus all of my nodes. So if I expand this out, I can see the 4 nodes within this cluster. Now let's take a look at one of the namespaces. So I'm going to take a look at my Redis namespace. And if I expand this out, I can then see the Redis replica set and the Redis service within this namespace. So I'm going to expand out the replica set, and we can see the Redis pod, and expand this out even further, and I can see 2 containers inside of this pod. So we have a Redis exporter, which is collecting metrics from the Redis application and exposing that to Prometheus. And then there is the Redis container itself where the application exists. So if I click on the Redis container here, I can go into my Prometheus metrics, and this is something that we are just starting to experiment with, is getting application metrics into vRealize Operations. So I can see a whole bunch of application metrics here. So for example, how many clients are connected to Redis, right? I can scroll down here and pick another metric. Maybe I'm trying to troubleshoot some connection issues here. So I can go and take a look at how many connections were rejected. So you can see how powerful this is, right? I don't need to learn any sort of new query languages to get this sort of information. So not only can we go really deep into our Kubernetes metrics, we can also go really wide. So if I look at my Tanzu cluster node here, and I can see the virtual machine that that node lives on, I can see the Tanzu cluster that it is part of, as well as all the pods that live on that, right? That's all fantastic. And of course, I can go even wider and expand out the virtual machine that that node lives on, and I can see the Tanzu cluster. I can also see the ESXi host that that virtual machine's running on, and I can expand it out further to look at the cluster and data center and vCenter and all of that. Now, all of these relationships play into tools like the troubleshooting workbench. So this aims to show us interesting metrics and changes in our environment that could help with troubleshooting. So for example, the events here. vRealize Operations learns what's normal for every metric that it collects, and if those events fall outside of that normal range, they get highlighted here. Also, alerts get shown under here. We'll also show any changes that happened. So for example, here, somebody enabled a load balancer. And then the anomalous metrics. So are there any metrics that have a significant change during the time window that we're troubleshooting? So in this case, 6 hours. Now the object relationships come into play in the troubleshooting scope. So this allows us to select an object and then decide how many layers below and above that object we want to include in our troubleshooting. So for example, we can see the container, the pods, the node, the virtual machine, the ESXi host that that virtual machine lives on. And scrolling down even further, we can see the vCenter, the vSAN cluster, the resource pool, the vSphere cluster, right? All of that is included in our current scope. And when I find an interesting metric, I can pin it and use it later. So if I go into my metrics tab up top, we can see this metric. So not only can I collect all the various interesting metrics that I found throughout this troubleshooting exercise, I can also run correlation. So I can correlate this against all other metrics for our given object. I can look across all my peer objects, or I can correlate it against every metric of all the objects that are within the scope of my troubleshooting workbench. And so this makes it very easy for me to trace an issue from, in this case, an application running in a container, all the way through to my vSphere cluster. So I hope this demonstration has helped you to see the value of managing Kubernetes with vRealize operations, both leveraging vSphere with Tanzu, as well as the management pack for Kubernetes.